All right, here we go. We've got a question here about a nucleus of element X, which has a radius r and density ρ, and we want to compare that with another element which has 8 times the nucleon number. As ever, take some time to try the question, and then when you are ready to go, watch my attempted explanation. Okay, so it's quite a nice question when you sort of work out the maths of it. Let's firstly think about radius. Now, we should be aware that we have a radius which goes with a to the 1 over 3. This is in your data booklet. So what this says to me, whatever a is doing, we're going to take that to the power of 1 over 3, and that's going to change r. Now, in this case, we are multiplying a by a factor of 8. So hopefully you can see they've chosen that 8 for a reason. If a goes to 8a, then r is going to go to 8 to the power of 1 over 3a. Now that's quite nice because 8 to the power of 1 over 3 is 2. R is going to double. Okay, so we can get rid of 2 answers here. Okay, because just by multiplying that number of nucleons by 8 does not give the same factor in terms of the radius. And that kind of makes sense. The interesting bit here is in the density. Remember, our density is the ratio of mass to volume, where the mass is simply A, the number of nucleons, times the mass of each nucleon. We're then going to remember that volume goes with r cubed. So if we take our volume here, we're going to have a value here 4 over 3 r cubed. It's going to go with linearly with A. Hopefully you've seen here is if we then do our density calculation, that's A times U from the mass divided by an A on the bottom. Well, as a result, we've got a 3u over 4 pi r0 squared, r0 cubed. Now this is really going to be a constant value. Okay, you notice that it does not depend on A, does not depend on anything other than these combination of these constants, 3u 4 pi r0 cubed, which means that the answer here is D. Now what this says to us, if you're going to have a takeaway, you can't do the maths, or you're maybe just a bit knackered and it's almost exam time, so you don't need to learn anything new, the density of all nuclei is the same. Okay, so they do not change. So the density of uranium is the same as density of hydrogen, same as the density of silver. It doesn't matter what A is, it is the same for every element, and that's quite a striking result, which you hopefully can prove yourself, but if you can't, use my explanation, that's fine.